In today's video, we're looking at electron diffraction. This is an important subject as it shows how electrons can act in a wave, in the way the waves do, and forming a diffraction pattern. This uses a Teltron tube. These are a glass bulb, partially evacuated, and they have a heater, which you use a 6-volt supply for, and also connected to that, the cathode, that is the heater, we have a high voltage. The other side of the high voltage is connected to the anode, and the anode of these tubes has a little window with a very thin film of graphite. And the electrons can pass through the graphite, but they get diffracted, a bit like light passing through a diffraction grating. And it's the actual atoms of graphite that is doing or the gaps between them, that are doing the diffracting. Now, I have an older tube that the heater got damaged on, and this is the business part of that. So the cathode is here with heating connections, and the high voltage connection, and the anode is connected via that, which goes to a connection on the other side, and the window is the whole circle in the middle of this. I can get the light on it, and you can actually see through that if you get the light right. Now, occasionally that whole graphite window will perforate, and the later ones of these were supplied with a little magnet on a collar that you can sit on the tube to deflect the electron beam slightly, to use a different part of the window. Now, I'm not going to connect that up and show you. Simon Polikoff has an excellent video on this. What I want to show today is an analogy using a laser. These came with the older tubes. The older tubes were Teltron part 555, and if you have the original box for this, it's Tel 555A on it. The holder is starting to disintegrate, but the main part of it is this disc, which has a diffraction grating in. It's a diffraction grating in sort of 2 dimensions, so it's a grid rather than just lines. It has a bearing, so it spins very easily. And we shine, so this represents the array of carbon atoms in the graphite. We shine a laser through it. I'm using a green laser. We get an array of dots from the diffraction. And if we spin that with the laser shining through it, we get circles, which unfortunately the camera frame rate turns into a sort of a strobed circles. They look much more like circles on the screen in real life. The old Nuffield Advancing Physics textbooks have a good explanation of what is happening on this diffraction pattern. So we can see they've printed a grid of dots in hexagonal patterns like the atoms in a film of graphite. And the idea is, if you and we know that a diffraction grating is lines that are very close together, several per millimetre. So if you look at this array of dots at an angle, you can see they seem to form into lines, and almost as you move round, you can see that almost any direction, you can see that they form into lines like a grating.